Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So I'd like to request our members to kindly engage us in the comment section, subscribe to our channel and also check the links of various videos that we have done either on social media and YouTube. Subscribe and of course invite more members so that we can be able to have a healthy discussion on various topics in mathematics, physics, chemistry and biology. So today's topic is basically going to be a concept of equations. And in this specific discussion, we're going to look at different types of equations and how we can be able to represent them or rather identify them in case we come across them in problem sets or in some of our discussions as we go by. So in this particular case, I mentioned roughly on the concept of an equation in some of our discussions. So today, I'm just going to give an elaboration for that. An equation basically is going to refer to a statement that two quantities are basically equal. So for instance, I can just give an example of 2 plus 2 is equivalent to 4. So therefore, this is a statement that is implying that the two aspects or these two specific quantities are equal. So this is going to be accompanied by an equation, equal sign, which is going to be given as such. So therefore, this is going to constitute what we refer to as an equation, which is a statement that is indicating that two quantities are equal. So these two specific sides or members of the equation on the opposite or the two sides of an equation are going to be referred to as members or sides of an equation. So therefore, in case I mention the concept of members or sides of an equation, then therefore that is going to imply that specific concept. So these are going to be expressions on the two sides of an equation, which are going to be referred to as members. So we have talked about the concept of algebraic equations or algebraic expressions, and these are expressions which are going to constitute one or two, which are going to constitute basically one or more unknowns. And I'd say that unknowns are going to represent real numbers in this specific case. So algebraic equations are going to constitute one or perhaps two knowns. And for instance, if I give this example for y is equivalent to 2x, this is an equation in the first case since it consists of two members, and then it's going to have this equal sign given as such. So this statement implies that the members on the two sides are equal, therefore it qualifies to be an equation. So an algebraic expression is an expression that is consisting of two unknowns given as such, and therefore we are spoken about the concept of unknown, so I'm not going to go into details on that specific discussion. So next we're going to look at what we refer to as identity. Now in our discussion about trigonometry, I've just given one of the expressions or equations which of course are regarded as an identity. And this of course is going to be the square of the sine and the cosine of a function, which are going to give us as such. So for an identity, it's going to be an equation which is going to be true for all values of the unknown. Now in this specific case, for these specific values of the unknown, then therefore they are going to refer to as unity given as such. I can just be able to give a general example which is going to be given as such. So for n, for this specific expression or equation, for n value of g that we're going to assign, then therefore it's going to be true for this specific other member of the equation. For instance, if I give 2, then therefore we can be able to do a substitution for 2, and then we have 6 into 2. This is going to be 8 into 2 given as such. So this is going to be 4 plus 12, which is going to be equivalent to 16. So therefore, an identity therefore is going to refer to an equation which is true for all the values of the unknown letter g that are given in this specific case. Now, apart from this identity, we're going to have another one that is referred to as a conditional equation. So for a conditional equation, we're going to see that this is going to constitute of a value that is only specific to the specific expression of the unknown, whereby if we have an example of 3g is equivalent to 9, then therefore the value for g is going to be given as 3. So therefore this is going to be specific on the value of the unknown that is given. Therefore this is going to be referred to as a conditional equation. And then we're going to look at what we refer to as a linear equation. Now, for a linear equation, we have talked about the concept of the equation of a straight line. For a linear equation, this is going to have the unknowns to the first power. And of course, I'm just going to be given an example of the equation of a straight line as y is equivalent to mx plus c. And therefore, we have said that for a linear equation, it's an equation that has the unknowns to the first power. And of course, it's going to be to the first power implies that to the first degree of that equation for this particular member of a unknown, which is going to be given as x. So therefore, we are going to see that for linear equations, they are going to have what we refer to as this first degree of the unknown. And we're going to see, of course, being given. So in graphical forms, we're going to see linear equations having the graphs of a straight line. And then we're going to look at what we refer to as quadratic equations. So this is a quadratic equation. Now for a quadratic equation, of course, these are going to be the highest exponent of the unknowns being given by the power of 2. For instance, you can just be able to give this one as 8y plus 6 perhaps, and this is going to be equivalent to, let me give it as a value of 0. Therefore, this is going to be a quadratic equation, whereby we have said that the highest exponential power is going to be, of the unknown is going to be given as 2, and therefore we can be able to see the others are just y to the power of 1, perhaps to the power of 0 and 0 at the other ends. Of course, we're going to see some of the equations which are going to be of a higher degree, but in a different video. So these are different aspects of the equations that we have mentioned. And of course, I've started by defining the equation as a statement that the two quantities on the members of the sides are equal. And I said about the algebraic expression which constitute one or more unknowns. I've talked about the identity, of course, expression, which is an equation which is true for all the values of the unknowns, and I gave an example of this specific identity. And for a linear equation, it's going to constitute unknowns to the first power or the first degree. And for for algebraic or quadratic equations, they're going to constitute unknowns of or exponential forms of the unknown having the highest power given as 2 as such. So I hope that these different sets of equations are going to assist us identify various aspects of applications. And in some of the conditions, like the linear equations that I've mentioned, which constitute graphs of a straight line, then therefore we want to apply them appropriately in case we come across them. So that is it for now, guys. Catch us in our next video. Kindly check in our description boxes for various links of other videos which we have done on the same. By God bless.